Have you ever wondered just how vast our universe really is? It's a question that has stumped humanity for centuries, and the answer is more mind-boggling than you might think. Picture this: the observable universe. That's the part of the cosmos we can see from our vantage point here on Earth, is estimated to be a whopping 93 billion light-years in diameter. But here's the kicker: that's just the observable part. There's a whole lot more universe out there that we can't see or even measure. Let's try to put that into perspective. Light travels at an incredible speed of about 186,000 miles per second. A light year, the distance light can travel in a year, is roughly 6 trillion miles. Multiply that by 93 billion, and we're talking about a number so colossal it's almost unfathomable. But the universe isn't a static entity. It's dynamic and ever-changing. In fact, it's expanding all the time, growing larger and larger with each passing second. It's like an infinite cosmic balloon being blown up, stretching out the galaxies and the empty space between them. And here's something even more mind-boggling. Scientists believe there may be parts of the universe beyond what we can currently observe or measure. These regions, if they exist, are so far away that their light hasn't had time to reach us yet. In other words, there are potentially parts of the universe that are effectively invisible to us, hidden in the cosmic shadows. So even though we've made incredible strides in understanding the universe, there's still so much we don't know. It's like standing on the shore of an infinite cosmic ocean, with the vast majority of it lying unseen and unexplored. So the next time you look up at the night sky, remember you're seeing just a tiny fraction of the whole universe. So, keep wondering, keep asking questions, and who knows, maybe one day we'll uncover more of the universe's infinite mysteries. Did you know that space is completely silent? That's right. As you venture beyond our atmosphere, the familiar chorus of life gives way to a deafening silence. But why is this so? The answer lies in the nature of sound itself. Sound is a wave, and like all waves, it needs something to move through. Here on Earth, that something is usually air. When you speak, your vocal cords vibrate, creating waves in the air around you. Those waves reach your friends' ears, vibrate their eardrums, and voila, they hear your voice. But space is a different story. It's not completely empty, but it's close enough. It's a vacuum, devoid of the air or water that sound waves need to travel. Without a medium, the waves simply can't propagate. So if you were to try and have a chat out there among the stars, your words would fall on deaf cosmos. That's why, when you're in space, no one can hear you scream. Do you believe that there is a planet made almost entirely of diamond? Well, welcome to the reality of our vast universe where such celestial wonders exist. Imagine a place where it rains diamonds, where the ground beneath your feet could be worth more than all the wealth on Earth. This is the exoplanet 55 Cancri E, a sparkling gem in the cosmos. Scientists believe that this exoplanet, located in the constellation Cancer, is composed largely of diamond and graphite. It's about twice the size of our home planet and 8 times as massive. However, its year lasts a mere 18 hours, and with surface temperatures soaring above 3,000 degrees Fahrenheit, it's hardly a vacation spot. This diamond planet is a fascinating testament to the diverse and surprising nature of our universe. It challenges our understanding of planetary formation and composition. So, somewhere out there, there's a planet that could be a jeweler's dream. How fast do you think light travels? If you're thinking, pretty darn fast, you're right. The speed of light is a mind-boggling 299,792 kilometers per second. That's so fast, in fact, that if you were to travel at the speed of light, you could zip around the Earth over 7 times in a single second. Now, this speed is more than just a cool fact. It's also a crucial tool for astronomers. You see, when we talk about distances in the vast expanse of space, we often use light years. A light year is the distance that light can travel in 1 year. Given that light can travel nearly 300,000 kilometers in a single second, you can imagine how far it can go in a year. So, when we look up at the stars, we're actually seeing light that was emitted years ago. The cosmos, in essence, is a grand time machine. Can you imagine what it would feel like to be weightless? Let's journey into the fascinating concept of microgravity, a unique characteristic of the great cosmic expanse we call space. Astronauts, those brave explorers of the stars, experience this sensation of weightlessness, but it's not due to the absence of gravity. Quite the contrary, gravity is very much at play. You see, when astronauts are in space, they are in a constant state of free fall. Yes, you heard that right. They are perpetually falling, but they never hit the ground. This is because their spacecraft is falling too, and at the same rate. This creates the illusion of weightlessness, a feeling of floating freely in space, unbound by the gravitational chains that keep us anchored to our home planet. So next time you see an astronaut floating around in space, remember, it's not that there's no gravity in space, it's just that astronauts are falling along with their spacecraft. Do you think we are alone in the universe? This is the question that has haunted humanity for centuries. The prospect of extraterrestrial life is a tantalizing one, and it's a topic that scientists have been actively exploring for decades. Our understanding of life is based on our experience here on Earth. We know that life, as we understand it, requires certain conditions to thrive. These include a stable source of energy like our sun, a hospitable climate, and the presence of water. But the universe is vast and diverse, and who's to say that life, in forms we cannot even imagine, isn't flourishing under conditions far different from those on our home planet. Indeed, the search for life beyond Earth is not just about finding aliens, it's about broadening our understanding of life itself. What forms can life take? What conditions can it endure? These are questions we hope to answer as we scour the cosmos. One key concept in this search is the habitable zone, also known as the Goldilocks zone. This is the region around a star where conditions might be just right, not too hot, not too cold, for life as we know it to exist. Planets in this zone could potentially have liquid water on their surface, a key ingredient for life as we understand it. But even in our own solar system, we're finding that life might be able to exist outside this zone. Moons like Europa and Enceladus, orbiting Jupiter and Saturn respectively, might harbor subsurface oceans warmed by tidal forces, providing a possible haven for life. The search for extraterrestrial life is one of the greatest adventures of our time. It's a journey of discovery that could redefine our understanding of our place in the universe. But as of now, we have yet to find conclusive evidence of life beyond Earth. We've detected tantalizing hints, but nothing definitive. While we haven't found definitive evidence of life beyond Earth yet, the search continues. As we venture further into the cosmos, who knows what mysteries will unravel? Who knows what forms of life we'll encounter? In the grand theater of the universe, the curtain is only just rising on the act of discovery. What if I told you that most of the universe is made up of something we can't see or detect directly? That's right. Welcome to the enigma that is dark matter. Dark matter is thought to comprise about 85% of the universe's mass. That's a staggering amount, especially considering we can't see it, touch it, or detect it directly. So you might wonder, how do we even know it's there? Well, it's a bit like the wind. We can't see the wind, but we can see its effects. We see leaves rustling, kites soaring, and we feel it against our skin. Similarly, scientists infer the existence of dark matter through its gravitational effects on visible matter. Imagine you're looking at a galaxy through a telescope. You see stars spiraling around the galaxy's center, much like how planets orbit the sun. Now, according to the laws of physics, the stars at the edge of the galaxy should move slower than those near the center, due to the pull of gravity. But they don't, they move just as fast. This led scientists to hypothesize that there must be some unseen matter, exerting additional gravitational force, causing the outer stars to move faster. This unseen matter is what we call dark matter. But dark matter is more than just a galactic speed booster. Its gravitational pull helps hold galaxies together, and aids in the formation of galaxy clusters. Without dark matter, the universe as we know it might not exist. Despite its crucial role, dark matter remains elusive. Scientists are still trying to pin down what it's made of. Is it a new type of particle, or is it something entirely different? These are questions that drive the field of cosmology. Dark matter is one of the biggest mysteries in cosmology, and solving it could revolutionize our understanding of the universe. Every new discovery brings us one step closer to unraveling the enigma, and who knows, one day we might just crack the mystery of dark matter.